Hello students, welcome to the course Digital Electronics and Computer Organization presented by Department of Information Technology, Sanjuni College of Engineering, Kopargaon. In this video, we will learn topic 2.2 flip-flops, part 1 from Unit 2 Sequential Logic Circuit. The outline of the topic is like this. In the beginning, we shall see SR latch. Then we shall see clocked SR latch and then D latch. So what is SR latch? Storage elements that operate with signal levels rather than signal transitions are referred to as latches. Those controlled by a clock transition are flip-flops. Latches are said to be level-sensitive devices. Flip-flops are age-sensitive devices. Latches are the basic circuits from which all flip-flops are constructed. The SR latch is a circuit with two cross-coupled NOR gates or two cross-coupled NAND gates and two inputs labeled S for set and R for reset. The latch has two useful states. When output Q is equal to 1 and Q bar or Q dash is equal to 0, the latch is said to be in set state. When output Q0 is 0 and Q dash is 1 or Q bar is 1, it is said to be in the reset state. So this is the implementation of SR latch using NAND gates. So the outputs of the latch, they are fed to the input uh, to the other flip-flop. So you can see that the output of the the NAND gate, one NAND gate is given as an input to the second NAND gate, whereas the output of the second NAND gate is given as input to the first NAND gate. Whereas the other inputs of the NAND gates, they serve either as the set input or reset put. This is the function table for the SR latch. So we shall go through this particular function table. So first condition is that when S is equal to 1 and R is 0, then the latch is said to be in this particular state 0 and 1. The latch is reset. Okay, so when S input given is 1 and R input given is 0. So let us see how it works. So S is 1 and R is 0. So as you know, the truth table of the NAND gate, if any one of the input is 0, then the output is 1. So irrespective of what is this particular output, the output of this particular NAND gate, it will be 1. Then input to this particular NAND gate will be 1, and as a result both the inputs of the NAND gate are 1, so its output will be 0. So output of the latch is stable in this case. So when you give the inputs 1 and 0, then the output is 0 1. So in this case the flip-flop is said to be reset when Q is 0 and Q bar is 1, the flip-flop is said to be the reset state. So unless you change this particular input, the latch will be in the same state. Okay. Now, when you give the input uh, S is equal to 1 and R is equal to 1, then uh, output depends on what was the previous input. Okay. So after S is equal to 1 and R equal to 0, if you give this input as 1 1, then the output will be 0 1. Okay, so uh, for this purpose, you have to assume that the previous outputs were 0 and 1. So as a result of this, what will happen? So this will be 1. So 1 and 1 bar, so output will be 0, and 1 and 0 is 0 and bar, so that is 1. So if earlier input was 0 1, then it will remain 0 1. Whereas if you give the inputs as 1 1 and earlier input was 1 0, then it will remain 1 0, that is this 1 and 1 bar will be 0, and this 0 and 1 will be 0, bar will be 1. Okay, so the output will not change. You can see that the SR latch won't change its output when its inputs are 1 1. Whereas when you give the input as 0 1, then in that case you will find that the output of the SR latch will be 1 0. Okay. Whereas if you give the input as 0 0, then in that case both the outputs of this particular latch will be 1 1, and this is said to be the forbidden state of the flip-flop. So never we should give the inputs as 0 0 to this particular latch.